So let's start our day one with Verilog. So what is Verilog? This is the first question everyone should know about that. That Verilog is a hardware description language, or it is a language which describes the hardware used to design, model, and simulate design electronics systems. So we will design a hardware like flops, latches, combination circuits, sequential circuit for shorts. So this language will design this thing. Okay, so like microprocessor, memory, and digital circuit. So these are the larger part of the circuit, but inside that there is flops, latches, or sequential circuit or combination circuit. So it was originally developed in 1984. So this is all the past of this. So we will not go there. So what is the main thing? That it is unlike C or C++ or Python, which describes software behavior. Verilog describes hardware behavior and structure. So software is like it has some sequential kind of steps, like C or C++ compiler has some sequential kind of steps. But hardware, it's not like that. Hardware, if you are using in hardware, you can simultaneously on camera, you can simultaneously on WhatsApp. Multiple things are going on a hardware. So it has to store internal process is also going there. So hardware cannot be sequential. It is parallel. It is having a specific circuit inside it. So we need a specific language for describing such complex things. So what physically happens in gate and flip-flops and logic. So what is happening inside your chip or your mobile, inside their hardware, like how electrons are flowing, how the functions are going on. We will describe this with the help of Verilog. So first of all, this language is used now from you can see 1984 to till now. We are using Verilog as our hardware description language. So it is very important language. So let's move forward.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So why we need Verilog? As I said earlier, before HDLs, engineers have to draw schematic of the circuit. Means they have to draw a single flop, then another flop, and it is a slow error-prone process. As you can see, our designs are becoming in billions of transistors, not like 10,000 transistors. So it is very complex process, and nowadays it is impossible to draw a schematic or something kind of thing without a Verilog. With Verilog, we can write hardware designs as text, code, simulate it to the chip correctness, synthesize it into actual gates. So in FPGA example are different. FPGA has switches inside that which will connect multiple gates, and you will write that language, and that switches will connect the gates, and you will get a proper circuit out of it. It is a little bit of FPGA introduction, you can say. So we will write a code, and as per that the switches will connect a circuit. For example, NMOS and PMOS connect, it will create a CMOS, and we can use that as an inverter. So that switches will connect like that. So FPGA or ASIC. ASIC is like you are designing a proper circuit, and that will synthesize to a proper circuit. Then you will have send this after checking and everything. You will send this to function, and you will get a proper ASIC circuit. So you can design with Verilog these kind of things. Gap between design and hardware implementations. So yeah, we can use Verilog easily now. With the help of Verilog, we can now implement a complex hardware. So let's start with our Verilog. You can understand AND gate like this. For example, we don't know what is our AND gate. So we know that AND gate has 2 input and 1 output. Okay. So this upper layer, this layer is our module and N module. We will cover this with this. This box is our module and module. You can understand it like that. And we will describe its input and output. So A and B are input. We will describe its pin of that module A and B, and output as a Y.